Hello everyone. This video we are going to talk about the continuation part of ADTs, and we'll be going to cover the language examples. As discussed in the previous video, we described the support for data abstraction provided by C++, Objective-C, Java, C Sharp and Ruby. So all languages we cannot cover in single video, and today in this video we'll be going to talk about abstract data types in C++, right? So C++, which was first released in 1985, and it is belongs to the C family language. That means when I'm telling it is belongs to the C family, you have to understand the features of C programming language will be enhanced to C++, or else C++ is adding features of C. And one of the primary components of object oriented programming is abstract data types. C++ obviously it is required to support them when I'm saying it is a object oriented programming language. C++ provides two constructs that are very similar to each other, which are the class and the struct. That's what structures. C with classes is pronouncedly known as C++ or C++ classes or types. A C++ program unit that declares an instance of a class can also access any of the public entities in that class, but only through an instance of the class. You have to understand here, C++ allows us to define a class. Now, what we define in class? What is the program unit to write a class? Using of class, we will declare instance of a class, and these are accessible to public entities. And encapsulation is one of the feature of object oriented programming features. Now, encapsulation is supported in C++, and we will be generally we say encapsulation is what wrapping up of data or combining individual classes together. So generally we will see encapsulation in C++ with the header files, that when you are taking some header file hash include IO stream. Now IO stream is what it is, having a collection of classes together. So where we used to say it is providing encapsulation not only through header files, but also it will be defined. The data defined in C++ class are called data members. That means it provides encapsulation even through classes. Now the data, what I'm going to define, what data will define instance of classes, we will define that only we learn from the past statement. The data defined in C++ class are called data members, and the functions methods defined in a class are called member functions. So C++ class is going to have data members and member functions. Data members and member functions appear in two categories, class and instance. Class members are associated with the class. Instance members are associated with the instances of the class. So we will be not going to talk about class members. We will be going to talk about instances of the class. Because when you wanted to, when you are dealing with the instances of a class, we will be talking about how memory will be created, how memory will be released after once completion of the usage. These concepts we have to see right now. All of the instances of a class share a single set of member functions, but each instance has its own set of the class data members. Now class instances can be belongs to static variable, stack dynamic variable, or heap dynamic variables. If static or stack dynamic, they are referenced directly with value variables. I'll show you some example over here. Now look at the example. Hash include IO stream int main double A is equal to 5. What does it mean? A is a variable and the value of A is static in the program. So this variable category belongs to static variable. Now this is what double B. B is what? It's a variable which is defined in the scope. And if you refer the videos of second unit, you can understand and you can get deeper knowledge how variables are termed as static, stack dynamic, heap dynamic. Right. Now what is static? The value remains in constant and the scope of the static variables are throughout this block. You cannot use the same A with the value of 5 out of the block. This is what mean of static variable. What is stack variable, or what do you mean by stack dynamic variable? That the value of this will be given at runtime and the scope of the same variable is throughout this block. So we are talking about the same. The instance of the class can be a static, it can be a stack dynamic, or it can be a heap dynamic. As far as C++ is concerned, if the variable is static or stack dynamic, they are referencing directly with the value of the variables. If the instance of the class is heap dynamic, they are referenced through pointers. Stack dynamic instances of classes are always created by the elaboration of an object declaration. The lifetime of such a class instance ends when the end of the scope of its declaration is reached. And this is what we were discussed, right? The scope will be when the declaration part is reached over here, the lifetime and the scope of class instances will be end. Now, heap dynamic class instances are created with the new operator and destroyed with the delete operator. Now look at this code. It's a sample code where I am taking the value of p value, pointer value. Initially I am taking as null, pointer initialized with null, and p value is equal to new double. Means what? I am requesting the memory to allocate for p value, and star p value is equal to some value. So we will be storing the value in this specific address. Now look at this, delete p value is what? Once after I don't want to use this variable, we will be deallocating the memory whatsoever is created for this p value. So this is what heap dynamic. Heap dynamic class instances are created with the new operator and destroyed with the delete operator. Both stack and heap dynamic classes can have pointer data members that reference heap dynamic data, so that even though a class instance is stack dynamic, it can include data members that reference heap dynamic data. The same you understood with the sample code which I wrote in C++. Now, a member function. So this is what up to here we learned about data members. Data member can be a general variable what I am using in the class. That variable can be a static, that variable can be a stack dynamic, that can be a heap dynamic. So up to now we were discussed about what? Data members. Now, a member function of a class can be defined in two distinct ways. The first is the complete definition can appear in the class or only its header. Member function, it can appear in the class or only its header. When both the header and the body of a member function appear in the class definition, the member function is implicitly inlined. Placing member function definition outside the class definition separates specification from implementation, and this is what a common goal of modern programming. Information hiding, it's also one of the feature which is provided in C++. A C++ class can contain both hidden and visible entities. When I'm saying it is visible, meaning they are either hidden from or visible to clients of the class. Entities that are to be hidden are placed in a private class, and visible or public entities appear in a public class. There is one more third category, and which is protected, which makes a member visible to subclasses but not to clients. So information can be hidden using of three classes: private class, public class and protected class. Now we'll talk about constructors and destructors. C++ supports constructors and destructors. C++ allows the user to include constructor functions in class definitions, which are used to initialize the data members of newly created objects. A constructor may also allocate the heap dynamic data that are referenced by the pointer members of the new. Constructors are implicitly called when an object of the class type is created. A constructor has the same name as the class whose object is initializes. When we are going through with this definition, it has same name, and then you can see overloading constructor also. But point to be noted, though the constructor is overloaded, parameter profile will be differentiated. That means unique parameter profile will be maintained, though the constructor will be overloaded. A C++ class can also include a function called a destructor, which is implicitly called when the lifetime of an instance of the class ends. So that's what we will be deleting the memory which variable process has been finished. So we'll do this work through the deletion operator, delete operator. Okay, so the next video we'll be going to explain you about stack ADT code, how it will be implemented in C++. Thank you all.